2003 Harvard MIT Math Tournament Round 7. A and B are two integers such that a plus square root of b is equal to square root of 15 plus square root of 216. Compute a over b. The very first thing that I observe is that even though both sides have square root sign, but on the right hand side there is a bigger square root sign that covers everything. I want to get rid of that square root sign, and what I do is I square both sides to get rid of that. Then I immediately get a plus square root of b squared is equal to 15 plus square root of 216. And I will expand the left side by applying a square root of a sum formula. So square root of a sum formula goes by a plus b squared is equal to a squared plus 2ab plus b squared. By applying it, then I get a squared plus 2 times a times square root of b plus b. Then it's equal to 15 plus square root of 216. Given that a and b are both integers, then a squared are also the integers. Then a squared plus b is also an integer. Then obviously in this equation, it's obvious that a squared plus b corresponds to the integer part, and then 2a square root of b corresponds to the square root part. Then we have two separate equations. A squared plus b is equal to 15, and 2a square root of b is equal to square root of 216. Again, I have square root sign on both sides, which I really don't like. I want to get rid of them by squaring both sides. Then I have 4a squared b is equal to 216. A squared b is equal to 216 over 4, which is 54. Now I observe that the sum of the two integers a squared and b is 15, while the product of these two integers a squared and b is equal to 54. So what I can do is I can try to find a factor of 54. I will rewrite 54 in terms of the product of two integers, but one of the integer is a perfect square. Then 54 is either 1 times 54 or it's 9 times 6. There is no third combination of the integers for which one of the integer is a perfect square. And then when you add up these two integers, it has to be 15. 1 plus 54, that's obviously not 15. 9 plus 6, that's equal to 15. So I know for sure that 9 plus 6, 9 and 6 is... So I know for sure that a squared is 9, b is equal to 6. Well, we're not done yet. So a squared is equal to 9, then there are two possibilities. Either a is equal to 3 or a is equal to negative 3. They have the same magnitude. The only difference is the sign. Then I go back to the original equation and then I check the sign of the root part. The irrational part square root of 216 has a positive sign. This means that square root of b, this means that a also has to be positive. Because 2 is positive, square root of b is positive, then the sign of the square root part totally depends on the sign of a. And since it's positive, a has to be positive as well. So a is equal to 3, b is equal to 6. Then eventually a over b is equal to 3 over 6, or 1/2.